Class, this lesson is primarily on inverse variation, but I need to pick up direct variation from Math 1 just by way of review. Two little formulas to commit to memory. Sometimes the word problems look intimidating, but I assure you they're really not. Direct variation is y is equal to k times x. And in every case, k is going to be what we call a constant of variation. Now, with inverse variation, the little equation is y is equal to k divided by x. And again, we'll always have this constant of variation. And these kind of problems really, the way I'm going to teach it, it breaks down very simply. They've always got two steps. First step is you solve for k, for the constant. Then you take the value for k, and in the second situation, you plug it in. So if you look at example 1 on your notes, and we read that as y varies directly with x, and y is 15 when x is 3, find y when x is 12. Okay, so the key word is varies directly. So y varies directly with x. That's the very first thing that you want to note. Then it says that y is 15 when x is 3. Well, how do we solve for k? We divide both sides by 3, and so k is equal to 5. All right, that's the first step. We've solved for k. Then we're asked to find, well, what is y when x is 12? Well, we need to know what k is, but we just figured it out. So we have that y is equal to 5 times 12, which is going to be 60. And that's literally as difficult as it gets. Now, in number 2, we have an inverse variation problem. It says that y varies inversely with x, so the k, the constant, is in the numerator. And it says that y is 16 when x is 5. Okay, well, that's cool. So now we need to solve for k. We'll multiply both sides by 5. And let's see, go to the calculator. We've got 16 times 5 is 80. So in other words, the constant in this particular problem is 80. Now, that hasn't solved the problem, but it has helped us find the constant. Now we're going to take the constant and plug it into the second situation. And here it says, find y. So once again, we're asked to find y when x is 20. And in fact, I've already messed up. It's not a direct variation, it's inverse variation. So the k needs to be in the numerator. The x is 20. So what is k? Well, k we just found out is 80. So we put the 80 up where k was, and lo and behold, y is equal to 4. All right, students, we're back to number 3. And we've got inverse variation, but they give us the y value to begin with, and we're solving for k here. we get K is equal to 50. We multiply both sides by 25. 25 times 2 is 50. Then we're given another y value. We're asked to solve for x. So we start off with the y value this time, plug in our constant of 50. We multiply both sides by x. Then over here we're going to divide both sides by 40. And so we have x is 50 over 40, which reduces to 5 over 4. And that was number 3. All right, number 4, we have a direct variation situation. And we're told that y varies directly with x. We're given a y value, 8. We're given an x value, 6. And we're first having to solve for k, which we do by dividing both sides by 6. And then 8 over 6 reduces to 4 over 3, 4/3. All right, so that's our constant. Then we plug it into the second situation. It gives us a y value. We're trying to solve for x. So 20 is equal to 4/3 times x. Well, you can divide both sides by 4/3, or if you remember, you can multiply by the inverse, which would be 3 over 4, which is 60 over 4, which divides out to be 15. And so that would be number 4. All right, students, for number 5, these are the word problems, and generally speaking, this is what you want to work towards. It says, when air is pumped into a tire, the pressure required varies inversely. Okay, that's the key word. That should trigger that little formula in your mind, y is equal to k over x, as the volume of air. If the pressure is 30 pounds per square inch when the volume is 140 cubic inches, find the pressure when the volume is 100 cubic inches. Now, I understand that this sounds complicated, but I want you to write it down just the way you read it. It says the pressure, we'll use P for pressure, varies inversely as the volume. So we're going to use V for volume. So for number 5, the first thing I'm going to do is I'm going to write out the equation. P for pressure varies inversely as volume. Again, I've got K as our constant setting up here. Then it says, if the pressure is 30 pounds per square inch, well, 30 goes in the P spot. If the pressure is 30 pounds per square inch, when the volume is 140 cubic inches, find the pressure, P, when the volume is 100. So again, they're giving you 2 situations. The first situation, you solve for K, then you plug it into the second situation. So let's solve for K here. We'll multiply both sides by 140. And so we have 140 times 30 is K. And I don't know what that is, but we'll find out quickly enough. 140 times 30 is 4,200. All right, so the constant is 4,200. Then it says find the pressure when the volume is 100. So we're again solving for P. This time we know that the constant is 4,200 and that the volume is 100 cubic inches. The volume is less. So we're going to take 4,200, divide it by 100, and we get that the pressure is 4,200 psi, pounds per square inch. And so that's the answer to number 5. Okay, number 6. Bob's dentist determined the number of cavities developed in a patient's mouth each year is inversely proportional to the total number of minutes spent brushing during each session. Okay, inverse means it's kind of upside down to each other, and it kind of makes sense that the fewer minutes he brushes, the more cavities he's going to have. Or looked at it the other way, when he goes to the dentist, if he's got more cavities this time, that means that he spent less time brushing his teeth. So it's it makes common sense. It says if Bob developed 4 cavities during the year in which he spent only 30 seconds brushing his teeth, how many annual cavities will Bob develop if he increases his brushing time to 2 minutes per session? Now, the student wants to be aware, I think, that you're dealing with 2 different units, seconds and minutes. So let's keep that in mind as we solve for K. It's inversely proportional, so we've got C for cavities is inversely proportional to time spent brushing. So the first situation, he's got 4 cavities in 30 seconds. Now I'm going to call that 0.5 of a minute because I can see that the others, we could do it 60 seconds times 2, but I'm going to go here, 0.5. To solve for K, I'll quickly multiply by 0.5, and so I get 0.5 times 4 is going to be 2.0. All right, that's our constant. That's going to determine the relationship. Then, how many annual cavities, we're solving for C, will Bob have if he increases his brushing time to 2 minutes? So it would make sense that he's going to have fewer cavities now that he's brushing his teeth more. And so sure enough, 2 divided by 2 is 1. So if he spends more time brushing his teeth, he will have fewer cavities. He had 1 this year compared to 4 before. And that's problem 6. All right, problem 7. When designing buildings such as theaters, auditoriums, or museums, architects have to consider how sound travels. Sound intensity, I, is inversely proportional, key word, to the square of the distance. All right, let's keep that in mind, from the sound source, D. Now here's the first situation. It's always going to have 2. If the sound intensity is 1 unit when the distance is 4 feet, what is the sound intensity when the distance is 8 feet? All right, so let's be thinking about that. We're going to write it down as we read it. If the sound intensity, that's going to be I, is inversely proportional, K over the distance, well, if the sound intensity I is 1 unit when the distance is 4 feet. Okay, now we're going to multiply both sides by 4, so hopefully you can quickly see that K is going to equal to 4. So here we have our constant. What will the sound intensity be, I, when the distance is 8 feet? So it's going to be 4 divided by 8, or in other words, 1/2. Now, does that make sense? That the farther away you are, the less intense the sound is? Sure it does. It makes perfect common sense. And that's number 7. Okay, in number 8, to balance a seesaw, the distance D a person is from the fulcrum, that's the spot right here in the middle, is inversely proportional, key phrase, to his or her weight in pounds. So Roger, who weighs 120 pounds, is sitting 6 feet away from the fulcrum. Eva weighs 108 pounds. How far from the fulcrum must she sit to balance the seesaw? And as you can see right here, it's not balanced. She weighs a lot less. She's on the right. So how much further back does she have to sit? We'll have to add to the seesaw to balance. Well, let's see. It says the distance D is inversely proportional, K over the weight. All right, this first situation, Roger is sitting 6 feet away. He's 120 pounds. So to solve for K, we're going to multiply both sides by 6. And I don't want to make a mistake, so I shall do this. 120 times 6 is 720. So the constant is 720. All right, second situation. Eva weighs 108 pounds. So how far from the fulcrum, in other words, we're solving for distance, how far, distance sub E, I'll call it for Eva, must she sit in order for the thing to balance? So we got 720 over 108. Okay, 108 is how much Eva weighs. 720 was the constant. So we'll take 720, divide it by 108, and I get 6.7. So she's going to have to sit 6.7 feet away. So if Roger is 6 feet, then in order to balance this thing out, she's going to need to be almost 7 feet away because she weighs less. And that's problem 8.